Hello dear students. Today we'll be discussing about the second unit or the third chapter of your class 12 physics, that is current electricity. So let's first understand what basically electric current is. So electric current, which is generated by I, capital I, is basically rate of charge per unit time. Okay, so rate of charge means rate of flow of electric charge through a conductor in a unit time is called electric current. It is denoted by capital I and its SI unit is ampere, denoted by capital A. So how to define 1 ampere charge? So if 1 coulomb of charge flows through its any cross section in 1 second, then the amount of current flowing is 1 ampere. So I equals to Q by T. So Q equals to 1 coulomb, T equals to 1 second, the current will be 1 ampere. Okay. So what is the direction of current? Remember, current is not a vector quantity. Current चाहिँ vector quantity होइन, but यसको direction चाहिँ हुन्छ. Okay, so you can ask why. अब हामीले त पढेको छ, if anything has a direction then it is called a vector, but why current has a direction but it is not a vector भनेर सोध्न सक्छौ तिमीले. आन्सर चाहिँ के हो त्यसको भन्दाखेरि, yes, current has its direction but it do not follow the vector law of addition. Okay, vector को जुन चाहिँ एडिसन ल छ, सब्ट्र्याक्सन ल छ, त्यसलाई करेन्टले फलो गर्दैन. Okay, so that's why it is not a vector quantity, but it has its direction. And what is the direction of current? What is the direction of current? The direction of current is opposite to the direction of flow of electron. Electron, if it is going from A to B, the flow of current will be from B to A. Okay, so in another words, अर्को वर्ड्समा भन्नु पर्दाखेरि, the direction of current is along the direction of positive charge. Positive charge जता मुभ हुन्छ त्यतै हुन्छ current को direction. So drift velocity of free electrons. So drift velocity भनेको चाहिँ कुनै पनि कन्डक्टरमा एउटा इलेक्ट्रोनको र्यान्डम मोसन हुन्छ र फ्री इलेक्ट्रोनको जुन चाहिँ एभरेज भेलोसिटी अपोजिट टु द एप्लाइड इलेक्ट्रिक फिल्ड हुन्छ त्यसलाई चाहिँ भन्छ ड्रिफ्ट भेलोसिटी. ओके, सो जेनरली इन मेटल्स वी हेभ द एभरेज अर्डर अफ ड्रिफ्ट भेलोसिटी इज 10⁻⁵ मिटर पर सेकेन्ड. रिल्याक्सेसन टाइम, सो रिल्याक्सेसन टाइम इज डिनोटेड बाई टाउ. सो दुईटा कोलिजनको बिचको टाइम, एउटा इलेक्ट्रोन यहाँ ठोकियो, फेरि फ्री कुद्यो, फेरि ठोकियो, र यो दुईटा ठोकिएको बिचको टाइमलाई चाहिँ भनिन्छ रिल्याक्सेसन टाइम. ओके, so derivation of drift velocity. How to derive the drift velocity? First we have to know the total number of free electrons. So total number of free electrons is given by capital N. So it is number density small n multiplied by volume of conductor. Volume of conductor is given by area into length. So n, capital N is equals to small n al. So how much will be the force? Force is basically charge multiplied by electric field. So taking the magnitude of the electron, charge EU मात्रै हुन्छ, vector गरेको छैन, त्यही कारण नेगेटिभ साइन नलेको, only the magnitude. So what will be the acceleration? Acceleration is basically force divided by mass. Force is equals to ma, we know. So acceleration force को expression E divided by me. Okay, so putting all the values we get drift velocity Vd is equals to small e capital E divided by m multiplied by tau. Okay, so this current we know is Q divided by T. So and this small t time is basically L divided by Vd. Okay, so putting all this value we get I current to be NEAVD. So this expression is very important, and next term we need to define is current density. Current density is basically a vector quantity. Please remember, current चाहिँ तिम्रो scalar quantity हो, तर current density चाहिँ तिम्रो vector quantity हो. Okay, so it is basically current per unit area. So J is equals to I divided by A. So A vector भएको कारणले गर्दा J पनि vector हुन्छ. So putting the value, we get J equals to NEVD. So A लाई मुनि ल्याए NEVD. So J equals to NE square capital E divided by ME tau. जुन चाहिँ VD को एक्सप्रेसन छ त्यसलाई पुट गर्यो भने त्यो हुन्छ. And this J is also sigma multiplied by E, जसलाई ओम्स ल पनि भनिन्छ. ठुलो क्लासमा गएर तिमीहरू पढ्छौ. जुन चाहिँ V is equals to IR छ, त्यो चाहिँ स्केलर फर्म अफ ओम्स ल हो. त्यो चाहिँ डेरिभेटिभ्स अफ दिस J is equals to sigma E बाट डिराइभ गर्न सक्छौ तिमीले. सो दिस एक्चुअल ओम्स ल चाहिँ दिस J is equals to sigma E हो खासमा चाहिँ. Okay, so sigma here is the conductivity of the conductor. Sigma is equals to n square tau upon me. Next is mobility. So mobility is basically the ratio of magnitude of drift velocity divided by electric field. How fast the electron can move, the mobility, movement ko kura आउँछ transport phenomena. Okay, this is mobility. Ohm's law, V equals to IR, this you know. Resistance is, you have studied in class 10 also. It is the opposition offered by the conductor to the flow of electric current, and its unit is ohm. Resistance of a conductor is equals to rho L divided by A. Rho is you know, it is resistivity of a material. Resistivity of a material कुनै पनि material को लागि fixed हुन्छ. Okay, specific resistance पनि भनिन्छ. Okay, conductance is opposite of resistance. You can practice these numericals for your better understanding of this concept. So the next important thing is you can practice the previous year's question. Okay, combination of cells. Cells basically are, what are cells? Cells gives you electromotive force, EMF develop गर्छ कुनै पनि सेलले, इलेक्ट्रोकेमिकल सेल्सले. केमिकल एनर्जी इन्टु इलेक्ट्रिकल एनर्जी कन्भर्ट गर्ने डिभाइसलाई भन्छ इलेक्ट्रोकेमिकल सेल्स. ओके, सो कुनै पनि इलेक्ट्रोकेमिकल सेलमा त्यसको आफ्नो EMF हुन्छ. EMF भनेको इलेक्ट्रोमोटिभ फोर्स. ओके, बेसिकली पोटेन्शियल डिफरेन्स, त्यसको दुईटा टर्मिनलको बीचको पोटेन्शियल डिफरेन्सलाई चाहिँ भनिन्छ EMF. ओके, द्याट इज कल्ड EMF. So internal resistance denoted by small r is basically the resistance offered by the electrochemical cell. त्यो सेल भित्रको आफ्नो resistance is called internal resistance. Okay, so what is the relationship between EV and small r? This relation, r is equals to E divided by V minus 1 multiplied by r is the relationship. Okay, when cell is charging, this relationship holds. V equals to E plus IR is the expression for potential when the cell is charging. Okay, combination of cells, you have two types of combinations, series combination or the parallel combination. This time you don't have to study the series and parallel combination of resistors. They have deleted the parts, so I am discussing the revised form of syllabus only. So this notes basically is dedicated for revised form of syllabus. You don't have to worry about the resistors combination, but surely you have to worry about this combination of cell. Use cells आउँछ. Series combination भनेको end to end जोड्नु, parallel भनेको line by line तल्लो माथिल्लो जोड्नुलाई भन्छ. Okay, so network combination को numericals you have to practice. So Wheatstone bridge is basically arrangement of chatta resistor. It is arrangement of 4 resistor PQRS. So what is the purpose of this resistor भनेको चाहिँ, in the balanced condition it gives an expression which is P by Q equals to R by S. So कुनै पनि तीनटा if you know, you can surely get the value of the fourth one. So PQRS मा कुनै पनि तीनटाको भ्यालु if you know, you can get the value of the fourth one. And next bridge is your meter bridge or slide wire bridge. Same हो, working principle meter bridge को पनि Wheatstone bridge को नै हो, same thing. And the next is potentiometer. Potentiometer चाहिँ के हो भने it is used to measure the potential difference between the two points. दुईटा point को बीचको potential difference नाप्नुको लागि potentiometer use गर्छ. And the principle of this basically potentiometer is it states that if a steady current is passing through a resistance wire of uniform cross section, then potential difference between any 2 points on it is directly proportional to the length of the wire between these 2 points. So potential difference चाहिँ कुनै पनि wire को दुईटाको बीचको चाहिँ directly proportional to the length भनेर भनिन्छ. So V is proportional to L र यो proportionality sign हटाउनको लागि you need to add a proportionality constant and it is denoted by K. V equals to KL, and where K is the potential gradient. Okay, potential gradient bhanincha K lai. So what are the applications of potentiometer? Potentiometer are used to compare EMFs of two cells of EMF. दुईटा cell को EMF लाई compare गर्नुको लागि potentiometer use गर्छ. एउटा expression पाउँछौ तिमीले E1 by E2 is equals to L1 by L2. L1 र L2 तिम्रो null points हो. Null points भनेको जहाँनिर राख्दा जकीको deflection 0 हुन्छ, त्यसलाई null points भनिन्छ. Okay, so this expression, from this expression, if you know L1 L2, if you know epsilon 2, you can find epsilon 1 or E1, whatever you say. E1 E2 are the EMF of two batteries, two cells. L1 L2 is the null point, distance of the null point, value of the null point, or the balance point, whatever you say. So तीनटाको value याद छ, L1 L2 र E2 को value याद छ भने you can find E1. So it is also used to find the EMF of the cell. It is also used to measure internal resistance of a cell. Internal resistance पनि use गर्न सकिन्छ cell को. Okay. Other things you can see from the notes. So I'll forward this note to you guys. This is one of the best notes I have got. This note is not made by me. I am repeating this thing again and again. I have got this from the internet. So among various notes which I have downloaded, I thought this is the best. And please remember, this notes is for your new compiled deleted part, like ignore गरेर new part जुन चाहिँ syllabus छ त्यसलाई मात्रै focus गरेर बनाएको notes हो. So you can follow these notes. Whatever given in this note is very, very important. Okay, so meet you next time. Until then, thank you so much.